Okay, so here is a few examples of the work I would expect you to do on the test. So I worked out three different types of problems. These are problems that you would see on the test from sections 7.1, 7.2, 7.3, and 7.4. First problem we're going to see is integration by parts. You will see that this is the problem right here. It's the integration of e to the x cosine x dx. I do look for your work. Please do work so it's submitted. I would like one problem per page on your scrap paper. I need it organized so I can go through it. I am not going to give partial credit if I don't have work. And if there's no work, I am not going to give credit. There's always work to show. So here's an example. In black, I wrote lipids over here. And I said let u equal e to the x du is equal to e to the x dx. I let dv equals cosine x dx and v equals sine of x. I'm using parts, so it's u to the v, u times v minus the integration of v du. I do my substitution. I get e to the x sine x minus the integration of sine x e to the x dx. I say I need to do lipids again, so I can find out what I want to use. I have an exponential. I let u equal to e to the x. Du is equal to e to the x dx. dv is equal to sine x dx. And v is equal to minus cosine x. I do my substitution. I drop the brackets. I move it to the other side and multiply by a half. And what's highlighted is my final answer. This is the minimal work I expect to see. I'm sure there's more work you could show, but this is the work I'd like to see. It shows me you understand what you're doing, and if you make a mistake, I can see where you made the mistake and I can give you partial credit. The next problem I made up of trigonometric substitution. It's the integration of x squared over the square root of 1 minus x squared dx. I see it's in the form of a squared minus u squared, so I'm going to use u equals a sine theta. I drew a triangle for myself over here, so I know what the parts are. I know that u is equal to sine theta, so du is equal to cosine theta d theta. Now I have to remember that dx has to get replaced with du, and du is cosine theta d theta. All right. So then I go through and I get the integration of sine squared, where x squared was, it's now sine squared, all over the square root of 1 minus sine squared theta, cosine theta. Then I convert 1 minus sine squared theta to cosine squared theta. I take the square root of that. That gives me cosine theta. The cosine theta cancel out. I now have sine squared theta, the integration of sine squared theta d theta. Now, I do take off for not putting dx's and d thetas. It's important to have that on there. This tells me what we're integrating with respect to. You may not see that as an important thing, but math is a language. It's like a punctuation. I need to know that you are doing it in terms of x or y or whatever, thetas, t's. It's important because when you go to Calc 3, you may integrate with respect to x and then with y and then with z. And the order matters, and that's why we have to write these things down. Go back to the problem. I substitute sine squared theta to be 1/2 times 1 minus cosine 2 theta. I integrate, and I say, well, I need to get this back into terms of x. So I note that sine 2 theta is the equivalent to 2 sine theta cosine theta. Now, if I had not put the c's here so far, I would not take off it. I'm not going to take off unless I don't see a c at the end. I don't care about the c until the end anyway. I just wrote that down for myself. With the substitution, I have 1/2 times 1/2 times 2 sine theta cosine theta. If you didn't write the 1/2 times 2, you just wrote sine theta cosine theta, I'll understand. I'm not going to take off for that. But I do have to substitute back. 1/2. My final answer is 1/2 the arc sine or inverse trig value of the inverse sine of x minus x times the quantity square root of 1 minus x squared plus c. The last problem, I made a more detailed partial fractions problem. It's x cubed plus 6x minus 2 all over x to the fourth plus 6x squared dx. What you have to realize is that I can factor in the denominator and x squared out, the GCF, so that gives me x squared times the quantity x squared plus 6. I set up my partial fractions, So a over x, b over x squared. Remember, since it repeats, I have to have one and then a second one. A over x, then b over x squared. It's irreducible, x squared plus 6, so it's a 6x plus d all over x squared plus 6. I multiply through it by the LCD, which is x squared times x squared plus 6, and I get x squared plus 6x minus 2 is equal to a times x squared, the quantity x squared plus 6, plus b times the quantity x squared plus 6, plus the quantity cx plus d times x squared. I first let x equal 0, and then I find out that b is equal to negative 1/3. I next expand it. Then I group my like terms. I see that there's only one term that has an x in it, that's a. So 6x is equal to 6ax, therefore the constants have to be equal to each other. A is equal to 1. Then I go look at x cubed, and that would be the a plus c terms. So a plus c has to equal 1. Since a equals 1, c has to equal 0. See, I'm showing all my work, where I'm getting my answers from. Then I still need to find d. Since there is no x squared term, the coefficient would be 0. So 0x squared has to equal the quantity b plus d times x squared. So b plus d has to equal 0. And since b equals negative third, d has to equal a positive third. I now substitute back in. I'll break it apart. I realize that this part here is in the form of an arctan. So I do some substitution. That's what I'm doing here. I'm going to say let u equal this, walk through. Here I'm now back to my final step, and I integrate. It's important to remember the absolute values on the natural log. Here I have the 1/3 times the 1x, and here's my final answer. Thank you very much. I look forward to seeing all your work at the test. Have a great day.